Okay, in your syllabus they also ask you to have an understanding of the Venturi effect. Okay, it's very much in align with the Bernoulli principle, and it's part of fluid mechanics. And like with this course, they're not expecting you to have an in-depth knowledge. So you do need to understand how it operates. Okay, so Giovanni Battista Venturi in the 1700s discovered this phenomenon, and basically what it actually says is if you have a laminar flow of a fluid, so I will do this, and then we come to a constriction in that flow, and the flow is still remaining laminar, and then we come to an opening again to the same size. Basically what happens is, and like we were talking about with the river, we already really looked at this idea in the last video, as the flow comes through here, your flow lines become constricted, and when the flow lines become constricted, they have to speed up, and then when they come back out here, they become less constricted. So what does that tell us? Basically, it tells us that we have, in this situation here, fast flowing air means low pressure. Okay, so this is lower pressure plus higher velocity, and either side we have higher pressure, slower velocity, both there and here as well. Okay, so on the wide sides of the pipe we have high pressure, slow velocity. In the center we have low pressure and high velocity. Now, how do you remember that? Well, you can, like I said, think back to the good old days when you used to play with leaves in the park and you're, letting them flow down a stream. Narrow stream, faster. Okay, that's how you remember it's faster in the narrow bits. Okay. The way to remember the pressure changes, the way I remember it is, for me it's easy because I have come from the days of before fuel injection in cars, okay? And there was a thing called a carburettor, and the Venturi effect's used in a lot of different devices. You might want to do some research into its uses. I think it's used for measuring velocity of fluids as well, and there's various applications. But one of the applications that comes to mind from older automobiles prior to electronic fuel injection. So electronic fuel injection is where the fuel is injected into the cylinder as a vapor at the right mixture of oxygen and fuel to create an explosive mixture. Now, once upon a time, we needed to get fuel into the cylinder. You can't just pour it into the cylinder as it is because it's not going to work very efficiently. It needs to be a mixture of air and fuel, okay? So a vapor essentially. And the way they used to get that to happen was you would have a thing called a carburettor. And basically what that was is it would have a butterfly valve in its top, which would basically open up. So that would be in its closed position, say. And when it opens, it would let more or less air in here through the manifold. And then the air comes to a narrow section. And what they do with that narrow section is, if the air's coming in and it's being constricted, this is lower pressure. And what they do with that lower pressure is they have a small pipe here with fuel. And as the air rushes by here, this low pressure creates a vacuum and it sucks the fuel out of that small opening and creates a vapor. Okay, and that's the explosive mixture of fuel and air that's required for a combustion engine to run. Okay, so good old days, your carburettor, it would have a filter on it to filter the air so you don't get debris coming into the engine, and that would be sent to the cylinder and the whole process runs. So that's a use of the Venturi effect, and that's how I remember that that's low pressure, because it's low pressure is a vacuum, it's sucking the fuel, and it's in the narrow section. So that's how you remember you have lower pressure there. Now the other way you can remember it, of course, is your classic version of the wing. So if you have a racing car, let's do a racing car first. It usually has a spoiler on the back to hold it down. And it'll also be designed so that the air rushing fast through this narrow section under the car, as opposed to over the top, this air is pushed and compressed underneath together. It creates a Venturi and it sucks the car down on the road, which increases the traction of the tyres on the road. Okay, so that's a use of the Venturi effect, of narrowing them. So you'll quite often find performance cars are very, very low to the ground. Okay, you know, you drive a Lamborghini, not like I do, you'll find that speed humps and everything else are a real problem. And then of course your wing, okay, at an angle of attack, you know that you've got slower air here and faster air over the top. And as long as it remains laminar, we have higher static pressure here and less pressure here because the flow is faster. Okay, so that is the Venturi effect. Okay, so now we should understand the Venturi effect. So we can just say, let's do the definition of the Venturi effect that I've got in my trusty textbook here, and that way we'll have a word definition of it. But you should know that basically it's about when fluids flow in a laminar fashion through a narrow opening, the velocity goes up and static pressure goes down. Okay, so we'll write that down. I'm just going to try and get the definition out of here so we don't miss anything. Okay. Okay, so the Venturi effect is basically about the reduction of pressure. Okay, so as a fluid flows through a constriction, its velocity increases and the pressure decreases. That is the Venturi effect. So write down what the Venturi effect is, and then watch the videos below, and that'll be our lesson for today. We'll make it an easy one for Friday. If you've got any spare time, definitely start making notes and start thinking about doing some revision. I'll see you in the next lesson.